Welcome to Digital 360 Summit 2020. We are the premier event for senior executives driving industry digitalization, decentralization, and decarbonization. 2020 edition is a free virtual event via Zoom. The dates are August 18th, 19th, and 20th, 2020, and August 25th, 26th, 27th, 2020. We want to thank our sponsors, Texas State University, Greater San Marcos Partnership, and Cedar. This year's edition has 70 speakers from amazing companies like NASA, Intel, SAP, CPS Energy, Brazos River Authority, Aclara, Direct Energy, City of Austin, Aclara, Dell, Engie, Exelon, Oracle, Tesla, General Motors, TXDOT, Vistra, Siemens, AT&T, National Grid, Itron, City of Los Angeles, Austin Energy, City of Colorado Springs, and Hunt Energy Network, and over 1,000 attendees. The program has 16 keynotes and 11 panels, followed by 11 white papers and 28 videos. The event covers multiple industry verticals like networks, energy and utilities, buildings and infrastructure, water and wastewater, public safety and new financial tools, smart cities, sensor and edge computing, big data and software, smart mobility, new regulations and business models, space and smart factory, and Industry 4.0. We are also introducing Texas State Cedar, a new industry research consortium focused on connected infrastructure research enabling big ideas and the topics covered in each of the panels. We at Texas State, Star Park, Cedar, the Greater San Marcos Partnership, and industry partners are focusing on building 9 living labs to transform applied research and economic development with the goal to delivering one digital world.
All right, welcome everybody. It's so glad to be with you. And we are on for a great panel and a keynote. The topic of this afternoon is sensors and edge computing. And we are, again, I can't wait to hear all what's going to happen here. But before I get rolling on introducing our keynote speaker, I would like to share with you one short video for the Cedar initiative that was mentioned earlier just a moment ago. And so if you bear with me for a moment as I share my screen, hopefully you all can see that. And so here is all you need to know about Cedar. Welcome again to Digital 360 Summit 2020. We have the sensors and edge computing keynote and panel just seconds away. I would like to introduce our keynote speaker. And as soon as I give you the hands off, Kumi, you are off to the races on sharing the screen. But Kumi Premathilake is the Senior Vice President of Advanced Metering Infrastructure in utility automation at Aclara, a company owned by Hubbell. And I am super excited that she's here. She's one of the brightest people in the industry, and she has quite a challenge running everything she does. So Kumi, you may be kind enough to give us any sense for your responsibilities if I missed anything, and feel free to take the screen and share your screen, and off we go.
Thanks, Andreas, and thank you to the audience for participating in the Sensors and Edge Computing session today. To give you a little bit of background on me, I've been in the industry for about 20 years in both energy and water, in engineering and commercial roles. I'm currently a Division Vice President for AMI and Services at Hubbell Aclara. How this relates to me is really my portfolio, within Hubble and Aclara, which includes sensors and grid devices, such as grid monitoring sensors, reclosers, cap banks, acoustic leak detection sensors, to name a few. Communications networks to bring all that information from those networks and devices, and then software and services to synthesize the information that you get from those devices and act upon that information. So let's get right to it. The keynote theme is harnessing sensors and analytics for a better future. So what does that mean? My team and I regularly speak with a lot of our utility customers to understand the most pressing issues that impact them. They tell us that their business models are evolving, and it is critical to have more visibility to the nodes in that ecosystem that makes up the grid. Most utilities are also thinking about the long-term roadmap, whether the solution that we provide to them is scalable, and whether they can innovate on that solution into the future. So this understanding brings us really full circle. The adoption and the growth of the sensors is a really big, critical foundation for the future of the smart grid. So let's talk a little bit about that exponential growth. Analysts are predicting there is growth across multiple industries, from agriculture to autonomous vehicles that you just talked about a little bit before. The estimate is that we will go from millions of sensors today to trillions in the next few decades. And so let's look at some use cases that are really interesting to us. For example, agriculture, delivering food to the masses is heavily impacted by weather patterns, water availability, and even human migration. So new advances in sensor technology allows food producers to predict the impact from these influences and secure our food supply. Satellite imagers can predict weather patterns, visual data from drones that's even used in the utility space can monitor crop growth and even the spread of pests, giving farmers valuable information so they can manage their crops. With all this information at their fingertips, farmers can increase productivity, implement sustainable business practices, and provide transparency to their consumers who want to know more about where the food comes from. And one of the most interesting area another area is healthcare. Healthcare sensors in healthcare has democratized the access to health data for consumers. Most of that data now are in the hands of consumers. Smart watches and medical grade electrocardiograms are available today to measure anything from a heart rate and even to detect any abnormalities. The Apple Watch uses green LEDs with light-sensitive photodiodes to detect the amount of blood flowing through your wrist. And then there are other medical-grade consumer devices using AI, artificial intelligence, cloud, and microelectrodes to deliver medical-grade EKGs to consumers. All these solutions enable consumers to proactively manage their lifestyle and also allow for greater control over their health. Autonomous vehicles, that's very, very interesting for us. Vehicles are equipped with multiple sensors like cameras, radar, LiDAR. These sensors allow the brain of the vehicle to understand its surroundings and also maneuver around objects. they generate massive amounts of data, and supercomputing capabilities are needed to process the data. And again, companies are using AI and machine learning to train and validate the data. So the adoption of these sensors and their exponential growth also delivers tremendous benefits to utilities. Just as we can monitor a human heartbeat, we can translate the same capability to the electric and water distribution grid. Essentially, we will be able to monitor the heartbeat of multiple nodes that make up the grid. With a combination of sensors, artificial intelligence, and even deep learning, we can rapidly gather and synthesize data. Just as we can detect any anomalies in a human heart, sensors allow us to have more visibility to the health of the grid, diagnose any anomalies, and proactively control grid assets. For example, from the information that we can gather from a grid monitoring sensor and even smart meters at the edge of the grid, we can control grid assets such as reclosers, cap banks, voltage regulators on the grid. A similar model can also be adopted on the water distribution network. We have pipes instead of wires, where we can listen to pipes with acoustic sensors that can locate and identify a leak based on the difference in noise signature between a leaking pipe and a pipe that has a normal flow profile. We can even control valves and pumps to manage water pressure and also the energy consumption across the water distribution network. The sensors on the electric grid enable utilities to deliver reliable power to consumers and minimize brownouts and blackouts. In gas distribution networks, utilities are using methane sensors to detect leaks and improve safety both along the distribution line and also at the home, improving safety for both crews and consumers. And a really interesting case here is that we're monitoring a gas leak at the home from the gas meter consumption data. Taking that a step further, we can also selectively identify a methane leak versus a household chemical such as bleach, reducing a false positives. So what are the really big positive outcomes for grid operators and consumers? Utilities are in the business of providing secure, reliable, and affordable power to their consumers. Sensors enable utilities to deliver on this fundamental obligation. In terms of reliability, smart grid sensors and even smart meters, grid operators can detect anomalies, including faults. When anomalies occur, sensors enable grid operators to reroute power to minimize the amount of downtime and also minimize the number of customers impacted by the fault. Let's talk a little bit about resiliency. During major weather events, meters acting as sensors can help utilities precisely pinpoint issues and determine rapid restoration routes as well as plan routes, ensuring crew safety. A use case here I had not envisioned relates to Superstorm Sandy. New York City was using the water meter data to identify customers who had not evacuated from their homes since they could see normal usage patterns. Another interesting use case for us is a pole sensor for overground poles with an inclinometer. It can detect a pole impact and also identify a drop conductor. From a public safety perspective, the pole sensor can be used as an early detection tool when a utility pole moves out of what we call a normal position. In the case of wildfire mitigation, grid monitoring sensors can help utilities through all stages of mitigation, including prevention, emergency operations, outage restoration, and infrastructure repairs. Distribution and sub-transmission lines don't always follow the road, as we say. Out in remote areas, potential equipment failures can occur because utility operators may not know about down conductors, equipment failures that are all possible causes that can ignite or spark a fire. These are very rarely visible to utility engineers. This is where sensors can provide significant visibility to potential ignition issues. With the data from grid monitoring sensors, utilities can take a proactive approach to mitigate fire risks. In terms of sustainability, the increasing adoption and acceleration of distributed energy and renewable resources is really enabled by sensors. This is because sensors can provide more visibility and also rapidly synthesize information to control grid assets in a grid consisting of bidirectional power flow. Efficiency, wide adoption of sensors combined with algorithms and AI reduce the time to collect and synthesize the data. This enables utilities to react in near real time for better outcomes, resulting in improved productivity and also lowering cost. So, what are the things that utilities are using that help them as well as their end consumers? With systems planning and optimizations, sensors can help utilities understand demand and also manage their supply to match that demand. They can also monitor the demand and supply and price energy based on usage patterns and as well as peak loads. From a perspective of customer experience, data from the sensors allow utility to pass that information to consumers, allowing for more transparency and also enabling consumers to manage their energy and water use. Smart maintenance. Based on the sensor data, utilities can proactively manage the maintenance of their grid assets, leading to improved operating costs and better reliability. And then finally, there's regulatory compliance perspective. Data from the sensors allow utilities to create a more transparent environment with both customers and regulators. So how can suppliers like us help grid operators? With sensors alone, we cannot deliver on the fundamental obligation of a secure, reliable, and affordable grid, power and water. There are additional key elements that complete this ecosystem. As a supplier to grid operators, we can see three key elements to this equation. The sensors and devices that enable the utility to have the visibility to the heartbeat of the grid and control assets. A strong communications network backbone to bring information back from the sensors to the utility. Utilities will need to think about a communications platform that can move data from many sensors with shorter latencies and larger data loads as they grow. And then software to synthesize the data from the sensors and enable actionable outcomes. Utilities will need a platform that integrates with many different devices and also systems. All these elements are critical to providing visibility and orchestrating the grid. So looking ahead, I see some tectonic shifts in the field of sensors and analytics. With the adoption and exponential growth of sensors, we will have massive amounts of data to sift through. The frequency of the data traffic will also increase exponentially. And advances in technology will lead to more precision in the data sets. We will also have more interconnection between the nodes on the grid. We will also need massive computational power to make sense of the data and also deliver actionable insights without a lot of human intervention. We also need robust security protocols to protect the grid from bad actors as we're doing this. So how do we make sense of all of that massive amounts of data, fast frequency, massive computational power required? We need a way to process and synthesize the data in near real time to drive those actionable outcomes. Data scientists at the Argonne National Lab is trying to answer that exact question. So they're looking at if you had 1,000 pieces of power grid equipment, such as transformers, cap banks, any assets like that, losing 3 of those assets could create nearly 1 billion potential failure points, which each of those failure points, which one poses the greatest risk to the demand, and what is the fastest action needed by the grid operator to fix that issue? This is the question they're trying to answer, and they're using artificial intelligence to do it. Deep learning is an emerging area of research that promises tremendous potential that may help answer that question beyond AI. Even though these terms are used interchangeably, deep learning is a subsegment of machine learning and even which is also a subsegment of AI. With deep learning, researchers are attempting to simulate a biological neural network, essentially how our brain processes information via a collection of nodes. The goal is for the machine to extract patterns from the raw data using those neural networks without explicitly being programmed. So there are a couple of advantages to that, as you may see. The ability to tackle dissimilar problems. When we think about emerging sensor applications, they're mostly event-driven. Traditionally, sensing has been scheduled, meaning we are measuring a variable on a scheduled basis with the expected outcome. But today, an increasing number of those applications are based on some sort of event. For example, we can predict weather events and their consequences. We are able to detect anomalies when they occur near real time without a lot of human intervention with deep learning. It solves for that problem with the ability to tackle dissimilar problems. Deep learning also overcomes the problem of feature extraction, meaning synthesis may take less time as it gets trained without intervention. For example, with grid monitoring sensors, we can get many signatures of events. The system has to be able to classify between an issue that is a line disturbance versus a failing asset that could lead to a blackout or a brownout. And then there's also the natural variation to data that is automatically learned. So AI and deep learning is really at an infancy stage where technology providers have to prove the value to the utility. But as we take those small steps, smart grid neural networks, I'm excited about that future. So imagine in the Argonne lag example, if you could essentially forecast the action needed to be taken by the grid operator near real time, micro or milliseconds. This will provide massive benefits to the grid operator and help them deliver on their fundamental promise to their consumers: secure, reliable, and affordable power. That is all I have for the keynote. Thank you very much.
Thank you, Kumi. That was fantastic. And as I understand, you're not going to stick around, or are you sticking around?
I can stick around for a little bit, so.
Okay, well, you're welcome to stick around as long as you like, and we know that Kevin will do justice to everything you have said and then some. But thank you very much for sharing your thoughts. I'm sure that the juices are flowing. Let me introduce you to Chris Germann with CMG, who is your moderator for this session. Chris is a principal and senior consultant with the CMG team, and we're lucky to have him, be associated with him. He came to us via Oracle and Gartner, where he has been most of his career doing all kinds of cool things related to digital transformations. Chris, take it away.
Well, thanks very much, Andres, and thank you, Kumi. Very enlightening. I think kicked us off in a big way here for the panel. Really want to thank everybody joining the broadcast today. We're going to get to as many of your questions as we possibly can. We already have a few in the question bar, so thank you for that. But as we discussed as a panel, we thought there were some pretty compelling issues to discuss up front. So we're going to get to those. But before we do that, I just want to make sure that you all know who's on the panel. So we're going to go through each person on the panel. If you could state your name, obviously your title, and then what your company does, just real quick for a minute or so we don't take too much time. And then from there, we'll get into the questions. So we'll start with Mark Federle. Mark, could you go first?
Sure, happy to. Thanks, Chris, and thanks for having me on the panel. Mark Federle from QinetiQ North America. I'm the managing director of our Smart Grid Solutions Group. And for QinetiQ, that really is primarily grid sensing and monitoring equipment. We have both medium voltage devices and low voltage devices. And they get used by utilities in multiple applications, many of which Kumi mentioned.
Excellent. Thank you. Giri from Sentient Networks.
Sentient Energy, yes, good afternoon, and thanks for having us. Sentient Energy is based in Burlingame, California, and we are a leading provider of intelligent sensors, software, and analytics to make distribution circuits more reliable, safe, and resilient.
Excellent. Thank you, Giri. Kevin from Aclara.
You bet. Thank you, Chris. I appreciate it. And thank you also to Andres and CMG for inviting me to be a part of this. I'm part of the same organization as Kumi. I have roles in both Aclara and Hubble, responsible for both of the company's grid optimization and sensing solutions, a wide range of sensors and some of the associated applications, as well as power factor correction solutions and some sectionalizing and switching equipment as well. It's a pleasure to be here.
Thank you. Appreciate that. Scott Hinson from Pecan Street Incorporated. Scott?
Hi, I'm Scott Hinson from Pecan Street. I'm the CTO. We are a bit different of an organization compared to some of the others here. We are a 501c3 nonprofit based in Austin, Texas. We have about 1,000 volunteer participants nationwide, where we have installed monitoring equipment and in some cases control equipment. These are typically residential structures. And as part of this program, we collect about 2.6 billion data points a day on how people are using and generating electricity, and how devices such as smart inverters and energy storage systems and demand response programs interact with the grid.
Thank you. I appreciate that. So you're going to help us solve the data problem that Kumi was talking about, right?
Oh, if you want data, we got data.
Wonderful. Okay. Mike Bates from Intel.
Hi, yes, Mike Bates, General Manager for Intel's Energy Vertical. My team is an overlay to the worldwide sales and marketing organization at Intel. Most folks would know Intel is a manufacturer of CPUs for computers and data centers, but we're also moving some of that compute and CPU power to the edge of the grid, the edge of the factory, to drive some of the new use cases that Kumi and the folks have talked about already. So looking forward to the panel.
Thank you. Appreciate that. And last but not least, Brent Lunceford, President of Memstronics. Unmute. Could you unmute, Brent?
Okay. Sorry about that. Thanks to everyone at CMG. Thanks for the panel. I think it's worth mentioning, so I'm the president of Memstronics. I work in all areas where you find MEMS and sensor technology. It's worth mentioning, I started my career at the world-renowned Microelectronic and Computer Technology Corporation, the think tank in Austin, Texas, known as MCC. MCC was established by the US government and 20 of the Fortune 500 companies in the United States, with the purpose of accelerating the commercialization of disruptive technologies and disseminating the knowledge and the technology into the US economy, with the sole purpose of regaining a competitive advantage in electronics. So many of the technologies that we talk about in panels like this and events like the CMG event, many of these technologies were developed at MCC, and if they weren't developed there, we were working side by side with DARPA, the Department of Defense, and the other top 3 government agencies to plan and develop a roadmap for the Internet of Things, the highly connected wireless ecosystem, and smart cities, etc. I've got a lot more I could say about that, but we need to get on with the panel. Again, thank you everyone for having me on this panel.
Absolutely. Thanks, Brent. And thank you everybody for that quick note. We've got a couple comments coming in already, but let's go with a few questions that we had queued up. So let's hit probably the most relevant issue right now for everybody. Everybody's world's changing, obviously, with the pandemic. And one of the questions that I thought would be interesting is, how is the COVID pandemic changing or disrupting energy flow, data flow, technology flow through business? How is it disrupting our previous paradigm? And what are the implications for sensors and everything? Because we know how to live differently now than we used to. So Giri, you're smiling. It sounds like you have something on the tip of your tongue there.
It's a great question, Chris. No, thanks for reaching out to me on that. But look, I think it's creating an opportunity for us to think about new business models and changing our old paradigms first and foremost. As you know, Chris, our customers, the utilities, have a very difficult task of keeping the lights on even in these extremely difficult times for us. As we speak, parts of our country are being attacked by hurricanes. Part of it have wildfires going on, and then of course we have COVID-19 all amongst us. How can we do more remotely with more confidence? How can we do things with a lighter touch, and when we're not always able to safely be on premise? I think it's opening up opportunities for utilities to now do some things that was not always palatable to them. Thinking in terms of software as a service, using more remote monitoring, which feeds into the sensor software and analytics revolution. We think our utility partners are, definitely thinking more along those lines as they play a very critical role in helping us move through this pandemic season.
Thank you. And knowing that grid and actually the fabric of society we run by sensors and edge computing soon, that's far beyond the energy grid. Mark, what do you see as a few of the main things that we're learning through the pandemic that could make its way into our everyday life, or what implications do you see for grid computing?
It's a good question. It's a big question. I'm not sure if I have the answers for it. I mean, my experience working with utilities they've been so challenged with just managing kind of the day-to-day fundamentals of keeping the lights on and keeping the systems going. You know, thinking about offering broader capabilities or broader offerings, I think is something that at this point they're more concerned with just, you know, the fundamentals, the blocking and tackling, the grid resiliency. You know, more than ever, people want to feel secure. I mean, everyone is feeling insecure on so many different levels. Keeping the lights on in the house, in the business is just, you know, fundamental. And my conversations with utilities is, you know, they're postponing maintenance work that has any kind of disruption component to it, just because they want to, you know, keep the lights on, keep the customer feeling as comfortable as they can at this point in time. Longer term, what are the implications? I mean, certainly, you know, you certainly hear a lot about, you know, the whole commercial real estate marketplace, and, you know, what are the long-term implications of, you know, this pandemic has taught us that we can all work remotely fairly efficiently. You know, businesses are still going to need space, but do they need 100% of the space that they currently occupy? So, and those commercial office buildings or other facilities that people go to work at every day, they are big energy consumers. So I think it long term has all kinds of implications on, you know, how we're going to be serving the market, how utilities are going to be serving the market, where the loads are, where they're, you know, and how to meet those future, you know, supply and demand issues.
So we're thinking, I think you mentioned the commercial business space. That is something that's incredibly changed the way that we're approaching it as a society now, whether we need that much business space. And do we need smart buildings now? Because we won't be in them very much. I don't know. There's a lot of schools of thought there. Brent, and then after Brent, anybody else want to raise their hand on this issue? I think you had talked before, and then we'll go to Scott, about kind of the flow of the innovation now going to the home, because everybody's in the home as opposed to business applications. Did you have a thought on that?
So I want to remind ourselves that just a few years ago, we were talking in smart city conferences and thought leadership about the advantage of humans coming together and living in close proximity to each other, and how important that was to society. We gave examples of in the 1800s, 1700s, 1800s, advancing into the second, third, and fourth industrial revolution, and those advantages. And we've really been disrupted now. We all know that, that's an understatement. But I can tell you from my personal experience, you've got my wife and I both living in a home that's larger than we should have, and we're both running global teams. Suddenly, all this sensing capability is important to us. We are running our home now more like a business in many different perspectives, from agenda to lifestyle to living environment. So I'm expecting to see some of the home automation really take off from this. And I think I'm seeing the signs of that with some of our companies that are in leadership positions, such as Silicon Labs. And I see a lot of preparatory hiring positions going on for autonomous vehicles and things like that. So it's really going to be interesting to see how this plays out, how people come back together and work in facilities again, because companies are planning for the future of mobility, just like this pandemic never happened. So we're really in an uncharted territory here.
Yep.
I'm fortunate to live in a home that's almost off the grid. So I'm less impacted from people that might experience brownouts and things like that. But we really have some situations going on in the country with California on fire, with droughts across the country, with hurricanes coming in, and of course the pandemic. I want to save some time for someone else to comment on.
Scott, I think you had a comment on that one.
Yeah, so we've actually, because we have this ground truth data at the sub-circuit level within the homes to second level increments, right? So we have homes that generate 10.5 million data points a day. We've actually been able to watch the shift in behavioral patterns, and it was drastic. It was nearly instantaneous. And it has continued. It has persisted. I'm actually delivering a webinar on entirely this topic tomorrow. So go to the Pecan Street page or send me an email or find me on LinkedIn and we'll get you hooked up. But like in March and April, air conditioning use was up 40% per normalized for a cooling degree day. Electric vehicle charging in the week following Austin's shutdown for, right after they shut down South by Southwest, electric vehicle charging was off 80% from historical averages, and things like that. So, we're exercising the refrigerator more often, and this has implications not only for pricing and pricing tiers. It has implications for how you run the grid, what other things you might want to do with smarter devices like energy storage, smart inverters, things like that. And not in the least, but it has implications for the lifetime and warranty periods of residential systems that are maybe not used to being exercised this much.
Well, thank you for that. Kevin and then Michael.
I'd like to echo and build on some of the comments from Giri. Smart utility infrastructure is really starting to grow. There's still a lot more that needs to be done. But as we work with our utility customers, whether that's electric, gas and water, and my role is more so with electric, it is amazing how often when they start adding more visibility to the network with additional sensors, it's just eye-opening sometimes. So they thought they had high load here and it's low, or vice versa. Oftentimes they have visibility where there's generation at substations and then at the endpoints with the customers, and in between, not so much. They have models. So adding that visibility really enables the people that are operating the grid, the engineers and the planners, to know what's going on. And oftentimes, when there's issues or concerns or questions about what's going on in between, they dispatch crews to go out and add additional devices or to go investigate. And it's just much, much better in this COVID world where they can know before you go. Do you really need to send somebody out there when you could have the sensors monitoring and at the click of a keyboard, you know what the conditions are. You can send somebody to the right place or avoid having to send their personnel out there. It's going to keep the utility people safer themselves.
Thank you. Michael, you want to add something?
Yeah, three quick hits. So I think first, and I know this was happening before COVID, and I heard somebody say this the other day, that COVID is like, bringing 2030 to 2020. It's like 10 years acceleration of the future. But a lot of that transition, I think, is happening in the oil and gas industry. And if you're following some of the recent announcements, like BP announcing a reduction of their oil production by 40% and reinvesting into clean energy, that's a massive transfer of value that those oil and gas companies, I think, are waking up to with the impacts on their business through COVID. Yeah, it's a massive. I think for our industry, the folks on this call, I think there's a massive opportunity there. I know the oil and gas companies are still trying to figure it all out, and they're spending quite a bit of money doing it. But I think putting edge compute out for new energy under those brands is going to be a massive opportunity, as well as something that Kumi mentioned around food supply. I think we also recognize the food supply chain wasn't quite as locked down as we thought, and COVID kind of exposed it. So instrumenting the food supply in a way to ensure we don't run into that problem in the future, I think is another one of those things that maybe is expediting the transition in that space as well.
Almost the everything supply, like supply chains, like for electronic parts, for mechanical parts. It was all, it all got a little crazy there for a while. It's still not right. It's still like, I don't know what you guys are seeing, but for our limited production, it's still not right.
Bacon and ham. Who would have thought you couldn't get bacon and ham?
And I'll just comment, when we were at MCC and we were mulling over this Internet of Things, and the refrigerator was the big topic in 1996, 97. And it was literally about expiring milk, right? Your milk is expiring, notifying the homeowner that he needs new milk, ham or eggs. So we're literally at that point now where there's actually value in that.
Well, when you mentioned something, Mike, about renewable energy and the emphasis from the energy companies on that, and it seems like the percent of renewables as part of that's being used is going to go up anyway, not because it's making progress on building it out, but because the fossil fuels are just not being used as much. So that's going to be a bigger part of the equation for sure, just because
huge wake-up call.
Aren't flying as much or driving as much.
Yep.
So here's a question that Kumi touched on in her keynote, and this came from the topic came from Matthew, who's one of our attendees as well. She mentioned that when you introduce a smart grid, or excuse me, an edge-enabled network with sensors, you potentially introduce billions of failure points. And Matthew's question is there any sensor or any segment of a network connecting sensors that has a potential to fail? How are these smarter sensor-based control systems addressing how to manage failure when some elements fail and the data stops flowing? And it seems like a darker side of all the positive we get from the edge computing. But any thoughts on are these networks just automatically built for resilience and they're going to be automatically redundant, or is that really something to worry about, the failure points of edge computing?
If you don't mind, I'll go first.
Please, Giri, and then Kevin.
Yeah, I think it's a great question. And look, I think there's a couple of paradigms that will change slowly in our industry, as it should and as it must. But the first one is that with the steady growth of distributed energy resources now, we are beginning to see the grid slowly go, more modular from a highly monolithic one-way flow, right? The second part of it is with the growing number of microgrids now, we are beginning to see this modularity inject some bidirectionality. Again, this is something we didn't think about. So sensors become an absolutely necessary part of managing this modularity, managing this bidirectionality. And then the key part of this, Chris, to answer the specific question is, we have to design a no single point of failure infrastructure.
Yeah.
Where the failure of any one sensor is actually inconsequential to the larger scheme of protection and control. So that's the common sense answer that kind of comes to me as I think about it. But I'd love for Kevin to comment.
Yeah, sorry, go ahead.
No, you bet. I agree with everything that the Guru was just saying, that you're going to have, especially as the costs are coming down, there's a much greater opportunity to have redundant information or multiple points that can be taken advantage of. Also, from the electric utility perspective, oftentimes utilities in their advanced distribution management systems, they will have real-time power flow models. And those are very sophisticated systems that can take advantage of knowing when they're getting some anomalous data that really needs to be discounted, and they're taking advantage of the broader suite of information they have from different points to build up that full model of what's going on in the network. So any one individual source of data doesn't take down their whole operation of the network.
Yeah, it seems like that would be table stakes. I mean, especially now when we're going to depend on those networks so much, that there won't be a huge vulnerability that we're not thinking about with edge sensors. Even though some of the actual sensors might be accessible by hackers or other bad players, it shouldn't be able to take out the whole network. I don't know how close to the reality that is. Anybody else have a thought there? Okay, well, we'll move on and assume that's the case. Here's an issue that came up while we were talking about things as a panel that I thought was just fascinating. And of course, sensors go beyond energy applications. And we wondered about the crossover benefits or opportunities between industrial sensors and personal sensors in vehicles, buildings, in smart clothing, or even implanted in medical devices. I think we've always thought of systems being siloed. You know, you're a system and you're just a system. A building is a system and a building's a system. But now when you personally with your system with wearable computing and devices walk into a building, you're now part of that system. And you should be able to gain benefit from walking into that system or whatever transportation mode or whatever. So anybody have any thoughts on the benefits of crossover sensor technology and whether we're there yet or what the opportunities are?
Yeah, look, I think I spent 20 years in healthcare and life sciences before I moved into the utility space. And the idea of a personal network, including the idea of an implantable chip in a human being, has been toyed around with for multiple times. And we can even ingest them, as you know, some of these sensors as part of the diagnostic process. I think the combination or the spillover effects to your specific question, Chris, is, do I now need to actually say I have arrived, or does my suit say Giri arrived at the point of repair? Yeah. So we have an opportunity for some unsupervised coordination that takes place across systems, across envelopes, so long as there is an authenticated player who's authorized to move from one envelope to the other, right? Yeah. So I think it raises the bar for proven credentials and safe players who are proven to be authenticated. Then they can have spillover multipliers of value. But on the other side, security experts would oftentimes come and tell you, if somebody's uncredentialed and unauthenticated, they can actually inject noise into the system or do something far worse. So the interconnectedness of multiple planes here, that we are talking about, cannot happen without a growing focus on a secure cybersecurity and cyber surveillance.
Yeah, software algorithms and security. Interesting. Mark, any thoughts from QinetiQ's point of view there?
Well, I think it is the kind of the big vision for the Internet of Things concept, where at some point all of these sensors are going to talk and exchange information with each other. And as you move from your vehicle to your home, it's like Bluetooth just automatically coming on in the car kind of thing. From my perspective right now, the utilities are still very much challenged with the data that they have, that they're collecting from meters and sensors and other componentry out on the grid that is sensorized already. That the thought of then interacting with other data from other sensors, I think is a bit of a leap at this point. But to Scott's point earlier, I mean, the data that his sensors collect inside the home is very valuable data for the utility to use in terms of managing load and delivering quality, reliable service to their customers.
Thank you. George even adds on a different question here, a tangential question from the Q&A panel, or Q&A chat room. And he says, how do we build trust into these complex systems?
Yeah. I mean, one of the things you always have to think about with these is what's the bad, right? Like if you are building a sensor-based system and you walk into a building and the outcome of that knowledge is the lights and the temperature is set to your preference. Okay, right? Like if that goes wrong, okay, you stand up, you fix it, you override it, assuming that functionality is there. When we do energy storage systems on the side of people's houses, right? The capability for bad, or the worst case scenario, that goes up a few notches, right? And so now we have to ensure physical security, cybersecurity, and then even if the system is asked to do something completely stupid that you don't want it doing, it's got the local overrides and hardware safeties to just ignore that and not do it, right? And so there's many layers that you have to install as the stakes get higher for if somebody gets control of this, what's the bad, you know, and things like that. And you know, from our perspective, since we're dealing with life safety type things, when we take control of stuff, we take that pretty seriously, right? So there's a lot, and some of it, you know, is, you know, the standard sorts of secure socket layer with high levels of encryption and, you know, all sorts of other stuff, and then there's other simpler things that we do that fall under the sort of proprietary. It wouldn't stand up necessarily to a security audit, but it's going to make life a little bit more difficult for anybody trying to break into the system. And we do that kind of stuff too, right? I mean, everything's under lock and key. We put security screws in the access panel, you know, I mean, stuff like that.
Trust seems to be always a function of what the trade-offs are. You know, I'll feel and I'll give my trust if my trade-offs. So I'll give my data on the network if I get enough benefit from my bank or something else, right? So
your bank account is insured and secured, and if there's a big, you know, if there's a big withdrawal that wasn't you, you get your money back, and the bank finds those people, right? So, but you know, and then for our scenario is you know, if the systems are at, you know, maximum outdoor temperature that we don't want them operating above, what if somebody got control and tried to charge those batteries or something like that? Like that could be really bad. So we have all kinds of stuff in there.
Well, what do you all think? Where are we with these edge sensors and networks? Maybe talk about energy specifically, but it could be other things, smart buildings or smart cities. Where are we on a scale of 1 to 5? Let's not do 1 to 10, but 1 to 5 right now with trust, or with the ability to have viable functionality, give benefits without, you know, too much worry. Anybody?
What was your scale again?
1 to 5. 5 being absolute trust, 1 being not very much.
Yeah, I'd say we're probably 4.
Okay.
Yeah.
That's pretty high. Kevin?
Yeah.
Yeah, I mean, I think it's generally pretty good. You don't hear too many scenarios where the utility provider was off. I think we're hearing more and more cases where, again, whether it's electric or water or gas, utilities are providing, you know, better information for their customers. They're helping their customers do better at things to save energy, save on their bills. You know, you see more and more smart thermostats, and the utility able to work with the customer to control the water heater to help save power, identify, let customers know when there's leaks. But that's just on the residential end. When you think about, you know, the smaller number of commercial industrial customers, but that's where so much more of the energy is going, and the dollars for the electric utility industry. So to have the ability for commercial customers to know, if I want to put a new business somewhere, open up a new shop somewhere, what is the reliability of the power in this area versus that area? You know, is this a first quartile or a last quartile utility in terms of reliability, or maybe parts of this utility's network? If the utility has that visibility, has made that investment to improve, that's going to make businesses come there, that's going to have jobs coming there, and then it's going to enable at a next level additional portals. A lot of times utilities, you know, have opportunities for demand reduction when you're having peak demand times in the middle of the summer. We're going to have peak demand costs, and they can participate with their commercial customers in particular to shed load to avoid some of those peak demand costs. You don't have rolling blackouts, but as they get more visibility what's going on in the network. It's going to enable, I think, richer portals where the utilities can let their commercial industrial customers to see what's really going on. And when transactive energy starts going a little bit more, it's going to be a richer and more real-time engagement between utilities and their commercial industrial customers.
Thank you. Appreciate that. Any other back of the envelope 1 to 5, or are we all convinced we're
if I may, I wanted to raise the bar and say it's a 5. And the reason I think it's a 5 is because control, as you know, in the utility sector is the niche of the SCADA advanced distribution management system area. And it's a very highly trusted network where every device going onto that network is pretty well vetted and the characteristics of data flowing from it are fully and well understood.
Yeah.
So anything that is going to be an advisory to that very trusted, secure, controlled infrastructure is by definition either a 5 or they're going to have to be pushing back on that.
Yeah.
Just because of the rigor that they've already set in place that helped them build this 4 nines infrastructure over the last several decades.
Very well. Thank you. Brent, you had a comment in the chat here about body area networks. Did you want to kind of approach the panel with that or give a comment on that?
Yeah, I guess I guess it's a thought. I mean, I've heard of, I've developed body area network technology. I'm not actually aware of this taking off or being adopted. So I'm curious to hear from panelists or participants on whether body area network technology exists. It doesn't have to be implanted or ingested or tattooed, but I think those were the intention of the electronic tattoo, was to give a body area network potential. And then would that give us more confidence in cybersecurity or our edge sensors at home and work and office of recognizing who we are? So I guess body area network, is that a reality yet?
Well, to the extent Fitbit is, I'm going to say a body area network is.
Yeah, but I guess to take it a little bit further, if we had body area network technology, we could already be doing the social distancing, et cetera, and perhaps there are some other countries that have adopted some more intrusive technologies. You know, here in the United States, we're concerned about many things that kind of minimize our ability to go around and actually do the tracking. So anyway, I'll stop at that.
Yeah, Scott, do you have any volunteers wearing body area networks that you're getting data from?
Not that we've created. I have plenty of employees with all of the Apple products. But I mean, it's at that point where, you know, again, because we so concentrate on grid interaction, carbon reduction through generation and efficiency. If we could do things with occupancy and building efficiency, and they already do that with commercial structures, right? But if we could do more of that with residential structures, we would be all for studying it and working on it.
Very cool.
I mean, Nest has occupancy sensors as it is, but that's limited to that room, right?
Yeah.
And so it's limited at best. Would be the polite way to say it.
Well, Mike, I have one for you to start. This is kind of an overarching question, if you could. Maybe Intel has a perspective on the viability of sensors in general. We've had this technology for years, and it seems like there's something holding us back from getting to the space age applications we've been talking about. Do you know of 1 or 2 or 3 things that are actually inhibiting implementation or value capture from the edge sensing technology? Because that seems like we've had that for a long time. And when are we going to really assume most of the value from the technology?
Yeah, it's a great question, and it's kind of related to one that I just saw on the chat as well, which is the power being consumed by all these new devices at the edge. I think one of the obstacles that we run into is, the OT-IT. Well, convergence sounds really positive, as if IT and OT are converging, but the real battle is when they're not converging. And so long in these industries, OT has run their workloads and their technology for operations, and then IT, of course, runs enterprise. But the way it's starting to evolve is it's almost all IT, all the way from edge compute and what data stays at the edge for what was just asked, for power consumption. So building out, I think, the true end-to-end solution for sensors back to the data center includes a tiered compute approach, where some compute or sufficient amount of compute is at the edge for AI inference, AI learning and control, and that data stays at the edge. And then there's other data that goes backhaul to the data center to learn what the edge did, and then learn better, and the next time it runs a different, maybe a different algorithm. But that does require OT and IT to come together to work as one to solve that issue. And that has been, at least in our experience, a really difficult challenge, because they've never really had to work together. And I think this is really forcing them to work together. And then, of course, second to that is regulation. Not every industry is regulated. And I think there's folks on this call and panelists as well that are in the utility industry. So if you're working in the regulated utility industry, the regulators seem like they're a little further behind, and they need to catch up to enable some of this convergence to happen as well, and approve rate cases that are moving in this direction. I think, to me, those are the two big ones. And then the last one is just, I think, 5G. 5G is, for me, a big solution for what we're talking about, to enable a tiered compute so that you can manage the vast amounts of data going back and forth. But I think that's one area that is growing, and I think we're going to see a lot more of that, enabling some of the use cases that we're talking about today.
Very cool. So that's loaded with feedback there. Guys, I'd love some of your other observations. Mark, anything on what's inhibiting our use of the intelligence we've had on the edge for a long time?
Yeah, I think Mike touched upon, two issues that I run into quite frequently. One is, again, that convergence of IT and OT. And, frankly, in my experience in working with the utilities, you can convince the OT guys that, you've got a solution for them that they think is very cool. When they pull in the IT guys, they've got 9 months of backlog of work,
Yeah.
So it's going to slow the process down at a minimum. There's also just the question of, okay, if we put more sensors up, what are we going to do with all this data? And so, trying to find those applications that really drive value for the utilities is a big deal. I mean, I remember going to Distributech 6-7 years ago, and 2/3 of the vendors there were small software companies trying to, sell the killer app. And I think most of those companies no longer exist, or they've been absorbed by other companies. The other issue that Mike raised is just the regulatory environment. I think that, the purpose of the utility regulatory body is to drive reliable service for the consumer and essentially protect the consumer. And unfortunately, I think that leads to some short-sighted decisions on their part. The sensor deployments that seem to have the attention from the PUCs around the country are those that are for fault detection and location in the name of reliability and resiliency.
Yeah.
But there's so many other applications that fundamentally can help utilities operate so much more efficiently, that ultimately those changes, whether it's just through efficiency gains, through VAR optimization, or better visibility and modeling of the system, that ultimately are going to improve service, make the utilities more efficient, that are going to benefit the customer. And unfortunately, I think the PUCs have a hard time kind of seeing the business case that's going to benefit the consumer, and have a hard time allowing the utility to build it into their rate case. And so oftentimes it doesn't happen.
Thank you, Mark. Before we go to Kevin, to everybody online, we'd love to get your questions. So we're about out of kind of our pre-list of questions. So please type in your questions or comments or issues that you'd like to hear discussed by our expert panel here. Kevin, you wanted to add on to the inhibitors to getting value from our edge.
Yeah, I think the other panelists were spot on with the things that they pointed out. And a couple of other things I wanted to kind of add to them. Applications is certainly one of the drivers of having the right applications with the right value. In terms of communications, I agree with Mike that that's going to make a big difference. But there's two ways of thinking about it. Sometimes with all the sensor data, what are you going to do with it, right? And so in some cases, it's in a centralized location. You have all this data coming back to some centralized location. When you think about the IT delay sometimes in getting new applications spun up, there have been some regulatory hurdles in utilities being able to outsource some of the software, doing more software as a service, taking advantage of cloud-based infrastructure where some of the vendors can provide that as a service to the utility. There's starting to be some accounting and regulatory changes to allow utilities, regulated utilities, to rate base some of that, similar to the way they do capital purchases. So I think that's something that's a relatively new development that we're going to see more in some of all the sensor data coming back to a cloud infrastructure instance that can be set up in a heartbeat like that. All of the deep learning technology that Kumi was talking about earlier is really going to be able to take off when you have more of that type of infrastructure. But similar to the way Mike was talking about at the edge, right? So not everything is going to make sense to go all the way back to a big brain in the cloud. There are some evolving technologies and standards going on in the utility industry to standardize the way you can have edge computing, but still in the edge, the field area network of utility infrastructure. Open FMB, field message bus, is one of the things that some utilities have been spearheading. Duke has been one of the ones spearheading that. That's creating a standard where you could have intelligent devices, and they're not going to be the equivalent of cloud-based computing infrastructure in a centralized environment, but they're very targeted and localized intelligence that knows about some sources of sensor data in their part of the network, and they can be programmed to make localized decisions in pretty much real time. So I think as we see that get out there in the network, that's going to enable some of the applications we've been talking about.
Thank you. Scott, quick question for you to comment on, since one of the inhibitors seems to be data and algorithms or processing data, but if you think about it, I think Kumi mentioned it, it's processing the data so you can have a right outcome. If you walk into a room and you prefer a warm room, does it know you, and can it have that end result? That intelligence and that data gathering and processing is probably not there yet. Data gathering, yes. I don't know. What do you think from your point?
So for our perspective, it really depends on what you want to do. The first part of this is going to be music to Mike's ears, right? So when we look at our 1 minute or 15-minute data streams of energy usage, we can typically do that in a centralized resource and do it with relatively low latency and turn something around and make a decision on that. If we start involving the 1 second data streams, if we have a number of houses that we do that with, that bogs down. Like if we want to do simply how many air conditioners are on right now at this very instant. That can take time, and in fact, it takes long enough where if you haven't done that right, and this is for demand response purposes, some of those air conditioners will be off and different ones will be on. So you never get the answer quite right, right? And so if you want super fast reaction, if you want for these sort of energy systems, a lot of that compute has to be in the edge, right? And this is the part that's going to be music to Mike's ears, right? So you've got to now have the ability to measure, so that data has to be available at that edge, wherever you define the edge. And there was a comment from one of the attendees that was like, what do you define the edge? Well, it's tough, right?
Yeah.
So wherever you define the edge, it has to have the data, it has to have the compute horsepower to run the right algorithms, and it has to have the authority and the ability to make the decision and act on whatever it is that you wanted to do. So for us, for energy systems, right, we get by right now with fairly low cost, makerspace, Raspberry Pi, Arduino type things on the edge that can communicate with inverters and our sensors and make a decision. Do we discharge batteries, charge batteries? Do we do volt-var compensation? Do we do frequency watt compensation? Like, what compensation do you want us to do? Do you want us to not charge the car, charge the car? All these things can all be done in seconds, okay? If you need to get that to fractions of a second, then we need to amplify the magnitude of our compute resource locally and our communications out. I mean, it's just, it has to skyrocket. Like we just don't have, and it has to be cheap, right? Like I can't put $1,000 desktop PC next to every inverter out there. That's just not going to work. The inverter was only $1,500. Well, I can't do that, right?
Yeah. Interesting. So Brent or Giri, did you have anything to add to this last issue?
Well,
yes,
I do have something to add that is related to your last question and related to some things that Andreas has mentioned in the chat session. We've discussed a lot about what's holding back the adoption of the growth of edge sensing and cloud computing. I think we all feel this. I feel strongly that this COVID pandemic, it's a global pandemic, and it is the primary business use case that will drive the increased market adoption from consumers and enterprise markets. It's going to be up to solution providers, product manufacturers to get the pricing right, to understand that pricing elasticity, and to get into the market and to make sure it works. And cybersecurity is always a concern. But this event is creating not just the digital transformation, it's creating the great digital transformation. A movement that's been occurring slowly over the past 20 years, but this is truly forcing everyone from our grandparents to small business owners to understanding the value of remote monitoring, remote sensing, and remote control to a certain extent. So I think the time is now for this to happen. We've got momentum from a market need. If we keep the economy moving forward globally, then we may see this really take off like we all planned on it years ago.
Thank you. Appreciate that. Very good thoughts. Giri.
Yeah, so a couple of things, right? And I think there was a question that were following in the chat as well, right? When you look at utilities with a good handle on their OT infrastructure, right? The SCADA, DMS, OMS, that kind of stuff, then they will basically tell you that to the extent where the OT infrastructure is in place, they have a pretty good view of what they are seeing, right? So the edge by definition, therefore, without dodging the issue, becomes what you're seeing on that span of the feeder or the laterals that hang off it.
Yeah.
Right? So just making it very, very practical for us.
And span of the feeder, you mean from a home or from a business or from a pipeline? Or...
Precisely.
Okay.
Precisely. Right. What do I know about that span rather than what I know about the nearest substation or the home next to it, right? So that becomes the operative edge, just to answer one of the questions from Mike McCaffrey.
Thank you.
The second point then becomes one of a paradigm shift in analytics, right? And I'll give a couple of examples we used to use in other industries. First is, it took us about 10, 15 years of fly-by-wire, and even today, we won't fly a plane without a pilot inside it, even though the plane can pretty much take off and land by itself.
Yeah.
It tells you something about human psychology. Now, we have drones, but those fly themselves without any humans on it, right? So this is very important because I think going back to the trust piece, we have to understand the consequences of letting things in an unsupervised learning way, right? To use the machine learning jargon, in an unsupervised learning way, give them control at the edge. And if the consequences are small enough that it won't harm the larger control fabric that we have put in place, then and only then, I think we will have the tipping point where we will let control happen at the edge.
So to put that on a finer point, if everybody in my neighborhood here decides to run their house at 65 degrees all day, every day for 2 weeks, that will have an impact, or maybe in the whole city, maybe not in my neighborhood. But I think what you're saying is the chances of that happening are pretty low. And so giving the freedom to act, at the end point, at the edge, will produce enough benefit and not harm the system as much. Is that
needs to produce enough benefit for us to give the control there, right?
Okay, got it.
Classic Six Sigma FMEA analysis,
Yeah.
right? As we talk about providing a base level of resilience and reliability for an essential infrastructure of electron flow, as we release control, right, from the centralized command and control systems to the edge, we have to make sure that we are operating in the same way other critical infrastructures operate. First, do no harm.
Yeah.
Right? That's how healthcare operates, and that's exactly how the grid will operate. Is first do no harm. If you're doing harm, hopefully that consequentially is much smaller than the larger fabric. Nobody's looking at a cascading brownout blackout scenario. Nobody wants that.
Yeah.
Right?
Well, gentlemen, this has been fascinating. I think we have about 4 more minutes before Andres is going to wrap things up. Any last comments or ideas maybe, or inspiration that you got from listening to the panel today that you would like to share? Just like 30 or 45 seconds going around the horn. Mark, can we start with you?
Well, I appreciated Brent's comment there. I think that in the current state of the world, the optimism is good to have, and I hope his vision is correct. I mean, what's kind of struck me through this conversation is, we've got the smart grid sensor guys up here from Aclara and Sentient and QinetiQ, and we're taking these macro kind of views of the larger grid, and then we have folks like Scott and Brent who are looking at more granular data at the edge, to use the term, and I think that the vision is, how do we gather all of that data at the edge and cross it over into, and interacting with the sensors that the three of us are providing to the marketplace. And there's definitely synergies there that would benefit both groups and ultimately the utility and the consumer.
Thank you. Mike?
Yeah, my closing comments. I think we're at a really unique inflection point. Whether it was COVID driven or it was already coming, I don't know, and I'm not a person that can answer that question, but I do think that we're going in a direction where things we're talking about today are going to, they're really going to manifest. It's no longer a promise. I think it's, we're moving into, scale. And, I look forward to our next panel and test my theory. But again, it's super exciting to be where we are today, because I think there's so many opportunities out there that are causing, coming from this disruption.
Thank you. Brent?
I guess in closing, I'll just have to say, I've been very impressed with what I know of our network. It seems like our network has held up pretty well against this test. And I don't think Bob Metcalfe ever envisioned everybody in the world being connected like we are right now. But I've been impressed with what I know of. Now, maybe there's a lot of things that I don't know or not aware of, but it seems like the network has held up fairly well.
That's a great observation. Absolutely. Giri, and then we'll wrap up with Scott's comment.
Yeah, look, I think it was very enlightening. Enjoyed the conversation with my esteemed colleagues here this afternoon, and I look forward to further such panels. Thank you, Chris.
You bet. Thank you. Scott, your impressions?
Well, you know, to wrap it up, I think, you know, we've talked a lot about the technology, the policy, the data, and that are needed for sort of a wide range of applications. And it's only when you really have all three of those in alignment that you move forward quickly. And we see, you know, there's relatively limited policy around smartwatches and getting your emails all for them, but there is extremely limiting policy around energy and things like that, and for very good reasons. But when we need to move, if all three of those things line up, the technologies that we can deploy for the energy system, the technologies that we can deploy for other systems are pretty incredible.
Awesome. Gentlemen, thank you. This has been outstanding, really enlightening. Really want to thank Kumi as well for introductions, and we'll turn it back over to Andre.
Hey, thank you guys, and thanks everybody for listening. Did we get to hear Kevin to wrap up? Kevin, you had any parting thoughts?
I thank you, Andres. I think the panel summed it up very well in terms of you know, policies and regulations are going to be an enabler or an inhibitor as we the evolution of the types of sensors, the costs, and the way we can integrate them all over the place is just going to grow, and it's going to be enabled by the applications, where the value is, and the infrastructure being there that we can help utilities. You know,
Yeah. So I want to thank everybody for your time, and great job, Chris, moderating this superstar panel. I'm going to stop recording. If you all want to, if you're listening and want to keep hanging out, I got a couple questions to ask the panel, but I'm going to stop recording now and thank them again. So big hand of applause. Thank you. Thank you, everybody. Good job. So we're done.